Okay, part two of our vectors discussion is going to focus on what we call components. And this really is what you'll talk about a lot about vectors in pre-cal and calculus. And components just means look at the left or rightness of it and the up or downness. And I guess if I were sophisticated, I would say the horizontal and the vertical separately. So components means basically just focus on horizontal and vertical separately. All right, forgive me if I misspell. Separately, meaning if I have this blue vector, let's call it vector A, and if you put a little arrow over top of an A, that means that it's a vector. Let's say that its magnitude or its length is 10, and let's say that it is pointing at a direction. All right, I'm not saying bearing, I'm going to put it in standard position. Let's say that its direction is, let's see, that would be 130, let's say it's 140 degrees. If I want to break this vector into its components, what I would like to do is to say how far to the right am I of where I started, and how, or excuse me, right or left, and how far up or down of where I started. So left to rightness, I am this far left of where I started, right? So this distance right here, call it x because it's horizontal, is the x, or the horizontal component of that vector. And how far up am I? Well, I'm that far up. I'm y up. So I just want to break this into parts, and it's basically going to be right triangle trig. All right, there's going to be a lot of sines and cosines. When we work them backwards, we'll have tangents. But I just want to break this blue vector that's 140 degrees, length 10, into separate x and y parts. So let's talk about how far left we are first. First of all, what you need to realize about the horizontal part is left is negative, right's positive, as you would probably guess, just like a number line. So how far is it over there? Well, if you make a little right triangle here, the x is always going to use the cosine, right? If we were going strictly by the right triangle, I would say this is 40 degrees, and I would say that x equals 10 times the cosine of 40, because my equation would be the cosine of 40 degrees equals adjacent over hypotenuse, which is x over 10. Then I would multiply both sides of that equation by 10, and the length x is 10 times the cosine of 40. So here's kind of a problem with approaching it that way. 10 cosine 40. It's fine if you want to do that. I get 7.66. Then I have to remember that it's negative because I'm going to the left. Here's another way. Depending on what you know about unit circle trig, we can just use the 140. The cosine of 140 degrees is negative. All right, it's negative 7.66 times 10, negative 7.66. All right, your calculator realizes that 140 degrees has rotated you over past north, over into the second quadrant where x is negative. So if you're more comfortable using 40 and just remembering that it goes left, that's fine. I would suggest use the 140, and then you don't even have to think about it. But one way or the other, you should know this thing is negative first and then positive because I go left and up. All right, so quickly then, what's the y portion? Y is going to equal 10 times the sine of 140, just like x was 10 times the cosine of 140. So 10 times the sine of 140, and it'll give me this as a positive number because it knows that the sine of 140 is positive, it's upwards, and this is 6.43. So some basic little right triangle calculations will give us the x and y components of this vector. All right, so there's a couple ways to write this. One way is in V-shaped parentheses, negative 7.66, 6.43, which tells me I went left 7.66 and up 6.43. You could also write it with what's called an I and a J. Basically, it's an I with a little arrow over it, plus 6.43, J with a little arrow over it. All right, so I represents the X direction, J represents the Y direction. One day you'll be in 3D and you'll have a K vector for the Z direction. So what I'd like to do is go back to vectors part 1, and let's answer this question again, except let's answer it using components instead of using the law of cosines. So I'm going to copy all this, and we'll answer it again over here. Let's just go over here. All right, so here's our question that we answered the other day by making a triangle and then using the law of cosines. So we still have 50 miles east. And by the way, you can use bearings in this too. It's not that if you're using components you have to use standard position. Then I'm going to go 70 at a bearing of 160. And my question is still, how far is it and what direction is it from here to here? So let's solve it, but with components. And what you're going to do is take each leg of the journey and break it into its X and its Y parts. So I start out with a 50 due east. All right, that vector is 50I plus 0J. All right, there was no up or downness of my first leg of the trip. I just went 50 exactly to the right in the positive X direction. So that makes this one a little bit easier. I don't even really need to break it down. It's already completely broken down. But let's look at this next part. If I want to figure out how far right and down the 70 part went, here are my options. You can form a right triangle like we did earlier. Here's one thing though. You know how a minute ago I said over here you could do either make a right triangle and use the 40 and then just remember that it's negative because the calculator would say positive, or you could just use 140. One hesitation, if you're going to use your calculator, you need to use the standard position. I would need to know this if I'm going to type it in and just get straight up how far left and right did this 70 go. So let's use standard position. That would be, remember this little piece down here is 20. So I would have 90, 180, 270, 290. 290 degrees is the same as a bearing of 160 degrees. Okay, so that being said, the X and the Y parts of this 70 are 70 cosine of 290 and 70 sine of 290. So let's figure out the X and Y parts. 70 cosine 290 degrees. So this thing goes 23.9 steps units to the left. So that's 23.9 I. And then 70 sine of 290 is negative. See how it knew that it was going downward. That's why it's an advantage to use standard position. Negative 65.8. All right, so that basically tells me this right here was 65.8. This up here was 23.9. All right, so if that changing it over to the 290 doesn't sit well with you, basically we could just kind of redraw what we know. We've got a right triangle down here. This is 70. This is 20. Again, because the bearing of 160 was my given bearing. And then you can break down these sides, get this as x, make sure it's positive, get this for y, make sure it's negative because we went downward. If that's better, if you'd rather do it that way, that's fine. Or you can figure out what the standard position of that angle is, that 290 right there. Make sure you understand why it's 290, and just plug it in straightforward, cosine sine. All right, so back to the main question. What is the length and the direction of the resultant? All right, the overall journey. Components are good because you can just simply add them up. How far right am I from where I started? How far is it from this amount of rightness to this amount of rightness? How far to the right did I go? I don't care at all how far up or down I went, just to the right. And that is 73.9. All right, no big deal. I just add the parts. How far up or down am I from where I started? I'm down 65.8. All right, because these two add up to negative 65.8. So now I know overall I went this far right and this much down. So how do I get the resultant? What we're going to do is build a little right triangle. 73.9 right, 65.8 down, and now this is my answer. That's here. I'm just making one big right triangle out of the multiple legs of the journey, each broken into their parts. All right, so how do we find out this distance? Well, this is a right triangle, Pythagorean theorem. All right, so I want to take the square root of 73.9 squared plus 65.8 squared to get my hypotenuse, and it's 98.9. All right, so far so good, 98.9. Remember, last video, what was the distance? 98.9. All right, so we're so far so good. Totally different strategy, not making a big triangle, just busting it up into its x and its y parts. Now, what about the angle? We also want to know the bearing from start to finish. So basically, what we want to know is this angle, call alpha, so that we can find this angle, the bearing. The angle is usually going to be found with an inverse tangent. All right, the equation I'm going to use is tangent of alpha equals opposite 65.8 over adjacent 73.9 into the calculator. Inverse tangent 65.8 divided by 73.9 gives me an angle of 41.7, which gives me a bearing of that much plus this 90 for a final answer of 98.9 miles, bearing 131.7. .9 miles, bearing 131.7. All right, so this is another sort of area where we will use vectors. Instead of just making a triangle and using a non-right triangle, using the law of cosines, we're going to force it into being right triangles by only looking at the x and y separately. All right, break each leg of the journey into its parts, form those parts together for a full journey, and then use a little right triangle, hypotenuse, and then inverse tangent to find the angles. All right, so this is video 2 on vectors. There's a lot of stuff for vectors. We're just scratching the surface just to connect it to our triangles unit, and that's it. Young out.